Hello, 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 everyone out there in the world of mathematics, and welcome to this video on prerequisite skills leading into learning combinations. Okay, so let's start here with factorials, which is a review from chapter 2 when you learn permutations and factorials. So in this first example, we have 8 factorial. Okay, and let's recall what that means. Factorial is notation for factors starting at 8 and decreasing by 1, whole numbers, ending with 1. So there's 8 factors here since we're starting at 8. 8, 7, 6, 5, 4, 3, 2, and 1. Let's fill in the 4. Okay, and that's what 8 factorial translates to. There's also a button on your calculator, n factorial, that you can use to calculate this as well. So going to my calculator now, it's on my calculator, which is, this happens to be a Sharp. The number 4, above the number 4 is n factorial. So I'd have to press the second function button to activate that. So on mine, I would type in 8, then I would type in second function, and then I would press that number 4 button to get the n factorial, and then it would calculate for me, and it's 40,320. So this is an example where maybe you're starting with 8 objects, and not maybe, you are starting with 8 objects, and you have to organize all of them into an arrangement. So it becomes 8 factorial. So there's 40,320 ways to arrange 8 objects. Okay, so that's factorial notation and permutations review. Let's do a few more. Okay, so the next one is 9 factorial over 3 factorial. So you can, if you recall, we can expand 9 factorial all the way back to 3 factorial, and the 3 factorials will cancel out. Okay, and this becomes 9 times 87, 9 times 8 times 7 times 6 times 5 times 4, and that's a way to reduce factorials. You can expand until you have a common factor that'll divide out. Okay, 3 factorial times 4 factorial, so this is another way of saying 3 times 2 times 1, which is 6, and 4 times 3 times 2 times 1, which is 24. Okay, so that becomes 144. Okay, so that's working with factorials. Now, working with permutations, which involves factorials. So 10p6, recall the permutation formula is n factorial over n minus r factorial. So it's npr. Recall the notation. So this becomes 10 factorial over 10 minus 6 factorial, which simplifies to 10 factorial over 4 factorial. Now you could simplify like we did above in question B, or there's also a button, an NPR button on your calculator. On my calculator, it's above the number 6. So the number 6 and above the number 6 is NPR. So I have to use that second function button again. So I would type in n, which is 4. Then I would activate the second function, NPR. And to do that, I have to press second function and 6. And then I would type in R, which is 6 in this case. So there's 10 objects to start, and when 6 objects are being arranged. Order is important. So that would become 10, and then I activate the second function. So I would type in 10, then I do second function on the 6 to get NPR, and then I type in R, which is 6. So there's 10 objects, and we're going to arrange 6 of them, and that becomes 151,200 ways to organize 6 objects starting with 10. Okay, and then we have a few more here. So let's use that NPR button on the calculator. So it's going to be 12, second function 6, to activate the permutation button 3. So starting with 12 objects, and we're going to arrange 3 of them. And that becomes 1,320 ways to do so. Okay. So that is reviewing permutations and factorials. Let's do one more. Let's do one more to work on simplifying here. Or maybe we'll do all 3 of them. Okay, so 7p3, so that becomes 7 factorial over 7 minus 3 factorial, and that's being divided by 3 factorial. So this answer is being divided by 3 factorial. So we're going to end up with 7 factorial over 4 factorial. And this is being divided by 3 factorial. Okay, we can combine that. So if we use, if we expand the notation, it becomes 7 times 6 times 5 times 4 factorial. If we expand 7 factorial, and we're stopping at 4 factorial because we have a common factor in the denominator, which is going to cancel. And then 3 factorial becomes 3 times 2 times 1, which is 6. And we have another common factor that's going to reduce. And we're going to be left with 7 times 5. 7 times 5, which is 35 ways that this could happen. Okay, let's do, and that was F. Let's do G now. So this becomes 11 factorial over 11 minus 4, which is 7 factorial, and it's being divided by 4 factorial. So we can expand 11, remove the factorial and expand it, so it becomes 11 times 10 times 9, 8, stop at 7 factorial, because the 7 factorials will cancel. And then if we expand 4 factorial, it becomes 4 times 3 times 2 times 1. So 4 times 2 is 8, so the 8 will cancel out. And 9 divided by 3 reduces to 3. Let me change the color on that. We'll do 9 divided by 3 in green, and that simplifies to 3. So this becomes 11 times 10, which is 110, times 3, which is 330 ways that this arrangement can occur. Okay, and finally, we have 14 factorial divided by 2 factorial, 5 factorial, 6 factorial. So 14 is going to expand to 14, 13, 12, 11, 10, 9, 8, 7, 6 factorial. The 6 factorials are common, so that divides out 14, 13, 12, 11, 10, 9, 8, 7. And then the 5 factorial and the 2 factorial. So let's expand 5, 4, 3, 2, 1. Sometimes, our calculator can't handle these permutation questions, so there was the skill to learn to simplify factorials without your calculator, which is what I'm trying to demonstrate here, using small numbers. Even though your calculator can handle 14 factorial, When we get to the higher n values, it won't. So let's start reducing. So we'll do 14 divided by 2 is 7. Then we could do 4 times 3 is 12 divided by 12. That reduces to 1. We could do 5 times 2. Let's change the colors there. We'll do 5 times 2, which is 10, and that divides out the 10. And the entire denominator is divided out. So we're left with 7, 13, 11, 9, 8, 7. Okay. So we'll use our calculators for that now to illustrate that we've reduced the factors and we've allowed our calculator memory to handle the computation now. And so we've simplified the factorials to a level of computation that our calculator's memory can handle. Even though the original factorials were small and our calculator probably could have handled that, just to illustrate the skill on how to reduce factorials to the point where your calculator could handle that when it was a larger n value. So we did, just to review here, we divided out 14 and 2, and that left us with 7. Then we divided, we did 5 times 2, which is 10, and that divided out the 10. And then 4 times 3, which is 12, and that divides out the 12. And originally we had done 6 factorial divided by 6 factorial. So we reduced all those factors to 1 through division, and that left us with 7 times 13 times 11 times 9 times 8 times 7, which is 504,504 ways that you could organize these objects. Okay, so that's reviewing permutations and factorials from chapter 2. And this skill is important because the combination formula, which you haven't learned yet, is very similar to the permutation formula. So let me just show you that here. So NPR, which you've learned already, is n factorial over n minus r factorial. And the combination formula that you're going to be learning shortly is n factorial divided by n minus r factorial. So far it's identical, with another division of r factorial, because combinations are not concerned with order. They're non-ordered selections. And permutations involve order. So for example, ABC is a different arrangement from BAC, even though the same objects are involved. And, this can be organized in 3 factorial ways. So there's 6 ways to rearrange ABC. But for combinations, those 6 ways aren't important. What's important is ABC selected, which means there's only one way to select ABC. Even though there's 6 ways to organize ABC, ABC, BAC, CBA, for example, that's 3 ways so far, all starting with different letters. But then we could flip A and C, and we could get BCA, and then we could flip BC, and we're going to get ACB, and then we could flip BA, and it'll be CAB. So those are the 6 ways, but 3 factorials was a faster way to count it, more efficient. So even though there's 6 ways to rearrange ABC, because order is important for permutations, for combinations, order is not important. So how many ways can they be selected? There's only one way they could be selected. Because whether it's ABC or BAC, it's the same letters. So you just count it once. So you divide by 3 factorial, which is that extra division here of r factorial. So I don't want to take away from the lesson. I just want to give you some preview here. So working with factorials is a very important skill before we start working with combinations, because they're used as well. So although we used factorials for arrangements with order, we will use them again for combinations that involve non-order. Okay, so that's the first part of this preview, prerequisite skills to studying combinations. Thank you for watching this video. If you like the video, hit that like button. If you want to receive alerts when there's new content videos released, new lessons, new review skills, new homework questions, etc., then please subscribe to the channel. You guys are awesome, and I'll see you in the next video.